Hi, I'm Ed Fullman, CEO of Foxtrot Code, and I'm also the author of this foxpatch. Foxpatches are our data applications, which you can find on Foxtrot Code. And this one, like all other foxpatches available on the marketplace, are free to download, whether they're created by me or someone else, and they can be combined into a new foxpatch so that you don't have to start from scratch. The intent here is that there's nothing faster than not starting from scratch, and that's what we're going to explore here with this particular foxpatch. Like all foxpatches, this one is created from three types of functions, which you'll see in the upper right corner of the screen: reducers, reformatters, and refactors. This particular foxpatch is full of reducers and refactors, and its purpose is to create the data that renders the map on the Foxtrot Code website that's called Chicago Homicide Patterns. There are some complicated algorithmic functions within this foxpatch, and the value of that is that you could download it and instead of recreating it, just use it. In the foxpatch creation process, you can combine foxpatches together from multiple people into a new foxpatch, and you can list it. And we keep track of each individual's intellectual property so that when someone wants to buy the finished work, they check out, and we take care of paying all the people involved if they wanted to be paid. So that process is explained in other videos. What I'd like to describe here is what this particular foxpatch does and give you an overview of that process. So as you see in the upper left corner here, this foxpatch starts out with some reducers that attach themselves first to the Chicago data. So we have data incoming from the Chicago police and the city of Chicago from their data portal that's hosted by Socrata, and we use that to pull down on the hour fresh data as they put it out, and then that data is put into an index so that it's available to all sorts of foxpatches that might want to use it. This foxpatch then attaches to that data set. These three pieces here work together to reduce the data down. These are all reducers. So the first one attaches to all Chicago data. The second one filters it down to only the last year. The third foxpatch here takes last year's crime data and filters out only homicides. And then we go through a process of cleaning up the data. So basically, first thing we do is, as typical in different kinds of crime data, you'll see the same case number associated with multiple events. That's because people are updating them and so forth. For our purposes, which the purpose of this foxpatch is to actually create a map, or the data for a map, I should say, we want to make sure we only have one record so we're not double counting. You'll notice as I click through here that in the left panel, descriptions I've given you about how they work, as well as what's inside of these foxpatches, is available for you to look at. So again, we're going to dedupe, which is a command, and we're going to dedupe with the case number. So we're going to only have one event for each case number. Chicago publishes their data, thankfully, with location information, so we don't have to try to apply it here with lookups as you would see in some of the other videos. So we just want to make sure that there is location data available in this foxpatch, and that's the main thing that we want to make sure that we have. So this looks for the latitude field being full, and if it finds that, then we know that we have a good record. There's cases where some columns in the data set may not be filled in for one reason or another. We don't want to have null fields, so this fills that with a string just in case we want to print something or something like that. We don't want anything to malfunction. And then this knot cleans up the time. So the time is in a floating point format. This sorts it out, makes it pretty so that you can use it in the map, which we do. And now we get into the heart of the foxpatch, this line right here, which begins with clustering. So Splunk and Foxtrot Code work together, and Foxtrot Code creates a foxpatch, which is an application that runs on Splunk. It's Splunk compliant, and this is actually a very graphical, pretty version of the Splunk language, and we let you do things that you can't do on Splunk. But the long and the short of it is we use Splunk to compile to, and Splunk has a command called k-means, which refers to the k-means algorithm to find clusters of numeric information in this case. And what we're asking this knot to do here is to cluster the geographic data, the latitude and longitude, into clusters for all the homicide crime event incident records. So we're clustering the homicides together geographically. This is a year's worth of data, so we're looking at a year's worth of geographically clustered data, and we're asking, in this particular case, for 30 clusters, which you could expand and produce slightly more refined data if you upped it into the 60s and 100s even. But for our purposes, 30 is fine. These are the kind of things you could change and experiment with. So once we have the clusters, what we've done is we've grouped these homicides into not necessarily neighborhoods or even blocks. It's really like a group that seems to be related through the k-means algorithm. And what we're going to do with that is we're going to search within the cluster. So the next step that we use is called transaction, which is another powerful Splunk command. This is used for finding patterns, such as in cybersecurity, of one event happening after another, finding relationships between a series of events, essentially called a transaction. And in this case, we're going to look through the clusters, geographic clusters at the homicides, and we're going to try to detect a pattern of time. In other words, one homicide occurring in a geographic cluster followed by at least one more in a 10-day period. And unfortunately, there's a number of these clusters, which may or may not, with some more refinement, prove to indicate that there is a relationship to these homicides, and that they may be not just geographically related and therefore some proximity, which could be valuable in a homicide investigation, but also the fact that they're occurring in sequence, which may indicate that a number of things. And our goal here is not to draw conclusions. It's really more about showing you how to build an application and enabling you to do that kind of thing, or build another kind of application that a researcher could use to draw another kind of conclusion. But what we end up with is sets of homicides. Somewhere we're looking for more than two occurring, so in a 10-day period. So we're going to end up with multiple sets of homicides. They're typically between 3, and I think there's as many as 11 or 12 occurring in the same 10-day period in the same geography, in the same cluster, geographic cluster. So this transaction command creates these sets of transaction. This knot looks through those sets and takes any with more than 2 homicides, unfortunately. And then this one then converts the duration which is the duration of time that it's actually calculated in seconds for a higher precision analysis, but it converts the duration between the first murder and the second into days, and then we keep going here. So this is a little bit more cleanup now and reformatting for the map, pulling out the latitude and longitude. So the cluster command creates what's called a centroid of whatever numeric information you gave it. In this case, we gave it geographic information to cluster. So these are geographic latitude, longitude centers for the cluster, and therefore for the cluster of homicides as well. And we pull out a latitude from the centroid latitude, a longitude from the centroid longitude. That's what these do. Pretty simple commands, basically pulling stuff out. And then we get into sorting the addresses. So we want to now create a list of addresses where these events occurred, these murders, and the times. So the first thing we do is sort the addresses lexicographically, and then we stitch time together. So in other words, the time of each event is stitched to the address to create a string of sorts. And then we finalize that process by formatting a description that's revealed when you click on the blue markers on the maps. This is actually that process. And then finally, a relatively simple command to get the map to engage. So if you run this foxpatch, which we do every hour or so, it creates it can be used, which is what we do. We create a report with it, which is a current version of the data. It's actually alive and interactive, a map. And that's what you'll see on the Foxtrot Code website. This is also attached to real-time dashboards, where you can look at the data in real time as it's coming in, which is a different kind of analysis, obviously. And that's what this foxpatch does. Now, you could reuse this work and skip a lot of steps that were kind of heavy lifting by simply adding your own work to this. And I'll just give you a quick example. So we'll pull down a refactor, and we'll attach it to the clean duration here. So let's see, clean duration, sorry. So we'll call this start new. And this is how you could start basically a new branch. And the way that a foxpatch works is wherever you run it from, whatever the end of the line is. Imagine this is a string, right? And it kind of branches here, obviously. If you ran it from here, it would trace its way back to the beginning. If you ran it from here, it would trace its way back to this beginning. It would skip this branch. So what that lets you do is create multiple versions, if you will, or experiments of your application and put them all in the same place so that you can test them in various ways and look for different kinds of things. But for someone developing, you can simply take the results at this point and start your process forward and skip all this down here if you didn't want it. And that's how you reuse a foxpatch and repurpose it. You could keep going on in an infinite work here. And what we expect will happen with multiple people working on perhaps this foxpatch is over time, people will pick up foxpatches that have been added on to multiple times, like a relay race. So someone could take this and build something incredibly more complicated and more precise than what I have here based on their experience. And they could skip all the stuff that I worked out to get the data into this foxpatch. And that's the whole idea, not starting from scratch. Well, that's all we have for today. Thanks a lot for your attention. See you out there.